everybody, and welcome to today's Active House webinar on advancing the Active House radar for people and planet. We're still waiting for a few more people, so if you bear with us for a minute so we can get a few more people in, and then we're going to get started. And already thank you, Ambra, for joining us from VELUX and sharing your insights about how to use and advance the radar. Hi, Lona. Great to see you already discovered the chat. So any questions that you have, any comments, please put them in the chat so we can hear from you and we can hear your ideas and your questions and answer them. Or you can use the thumbs up and we can see it as well. So perfect. Ambra, I think we should get started for the people who are actually kind enough to show up on time to this exciting event. There will be some people joining us a bit later, but thank you all so much for being here with us. Really, really excited to share this very concrete case study with you. Thank you all for the many questions that we received from you during registration. Ambra and I went through them, and we'll see that we can address as many as possible during the presentation. But there's also lots of time for Q&A, so we're excited to hear your questions. So to kick you off, just a little introduction to what we're going to do today. Quick, what is Active House? What are we doing with Active House? What's the Active House radar that we're talking about today? Then we're going to hand over to Ambra and hear from VELUX how we can use or build on the Active House radar to make it even more relevant to people and the planet. Lots of time for Q&A, and then we wanted to share a little bit with you what's in the stores for the Active House Alliance and how you can get involved. So about the Active House Alliance, Active House is an international alliance that puts people's health and comfort at the center of buildings while also trying to minimize the negative impact that the climate and the environment has. It's not a huge, complex technical standard, but promotes a more holistic, performance-based approach. And I think this is what makes it very popular. As an alliance, we are a group of members who jointly try to advance these standards. We're coming from academia, from industry, people who are designing buildings, people who own buildings. So it's a global, really vibrant community of people who want to create better, more people-friendly, more environmental-friendly buildings. One way that we do that is through our certification with the Active House label, our radar, that we're going to talk about more. We're also working through knowledge sharing, through inspiring people through the Active Houses that have been created around the globe. And of course, we'd love you to get involved as members, as people who use the radar, who join us in developing the radar further as well. So the principles on which Active House is built is comfort, environment, and energy. And the way that this is translated into our certification or into the radar is to develop some key criteria for these three areas. So for comfort, there is daylight, thermal environment, indoor air quality, acoustic quality. When it comes to energy, we're looking at demand, at supply, but of course also at the energy performance of the building. And then when it comes to environment, this is about sustainable construction, what materials were used, were suppliers from the regions where the building materials come from, and also the use and recycling of fresh water. So that gives you a little bit of an overview, and you'll find a lot more on our website. And of course, Ambra will talk about some of these details, these different indicators in more detail as well. As I mentioned, there are active houses all around the world that are using this radar. And it's not just you're either 100% on or 100% off the radar. It's a tool to evaluate where your building is, where your renovation is, and what can be done to improve it. And we have a wonderful booklet with very inspiring stories of how the Active House Radar helps in every different kind of buildings all around the globe to look at comfort, health, environment, and energy. Here is a map with some of the buildings that you can find. Active House started in Europe, so there's a lot of buildings there, but we are also active in North America, in Asia. So all over the world, you can find really interesting stories of active houses. And I think that's also what makes the standard very special because it's flexible enough that you can use it in different regions, in different climate zones, and make it work for you. So that gives you just a little bit of an overview. I know lots of you that I see in the call actually know the radar and active house very well. Hopefully that is a good framing to hand over to you, Ambra. Ambra Guglietti is the Senior Sustainability and Healthy Buildings Manager at VELUX. And Ambra, you've been working with the radar for a very long time, right?
Yes. Yes. Hi, everyone.
Mhm.
And
So
yes, we did work with the radar quite a lot since the founding of Active House. And now we try to work even more on it.
So with that, we're really excited to hear, what's working, what can be improved, and how you're using it to build on it.
Yes. Let's see if the control works. Yes. So as as you said, we try to advance the Active House radar, and after using it on many projects in VELUX. And first of all, I would like to go through the why we felt the need to advance it and expand it to new indicators. And let me see if it works. Yes. So starting here, starting from the two systems that we desperately need to connect because we are connected. So the planet and the people. And how do we measure those two systems is through the Earth system science for the planet and building biology for people. And it's a bit slow. Yes. And what we need to do especially in the building industry, in building design, is to really gather for both people and planet and connect as much as possible the impact that the building has on both. And this is something that Active House have always done, promoting the holistic approach. And we keep this approach to looking at the buildings holistically, looking through all the layers that there are between the people actually and the planet, through the building, through society, to the Earth system and the ecosystem actually. So we need this holistic system perspective rather than isolating these two systems. And this is sort of the big why, I would say. The big why, because we have climate science that is trying to tell us that we need to do more because we have transgressed already 7, actually 8 now. This slide is not even updated, but out of 9 of the planetary boundaries. And that means that the ecosystem and the planet health is at stake, and we need to do something also in the building industry. And I have this animation that is actually showing why. So we made this analogy with the blood pressure. So when you have the blood pressure that is high, you need to do something about it. But you cannot only just stop the increase. You need to actually bring it back to a safe limit. And this is exactly the same that we need to do with the planet health. So bring it back to a safe limit. Yes. And it can sound a bit complex because we have these 9 planetary boundaries. It's a very complex science. But luckily, the Stockholm Resilience Center helped us to understand what is that we need to focus on, because we don't need to focus on all these 9, and that would be even too abstract and far away for the building industry. But they told us that there are 2 boundaries that are actually the ones that if we measure those, we are actually taking care of all the others, because CO2 emissions is the indicator for climate stability, and biodiversity loss regulates the functioning ecosystem. And once we take care of the functioning ecosystem, all the rest will follow. And in the building industry, we are actually very we have a responsibility, because it might sound that the biodiversity loss is far away. Why should we care? We are designing buildings. Why should we now account for biodiversity loss? But actually, it's something that we are all responsible for, and we know from WWF that the world's monitored wildlife population have shrunk 73% since 1970, and that's a quite worrying data. And also, now we know, and it has been measured also by WEF, the World Economic Forum, that the built environment is responsible for 29% of all threatened species. And the connection here is because the building industry is a very heavy resource user, using a lot of materials, and all the production of those materials are actually impacting the biodiversity. But we are also in a position, in a good position in the building industry, because we have a lot of research and methodologies that can help us calculate the impact. And we know already with the CO2 emissions, we have life cycle assessment, we have very comprehensive databases that are becoming better and better, also thanks to manufacturer updating the data on products. But we also have now a model. This is one of different models, actually. It's not the only one. The Impact World Plus method that has been developed at the moment in Denmark for biodiversity loss caused by buildings. And there are different methodologies, also something called GLAM and other methods that can be used to assess the biodiversity loss. We still have a long way to go for the data, because we don't have specific data on the biodiversity loss of materials and products also. But there is a lot of work happening at the moment on having more localized and regionalized data on biodiversity. So there's hope on that. But once we know this from Stockholm Resilience Center, then how do we use it? How can we create a framework that brings those 2 core system boundaries, how they call it, into action? How can we actually use it in the building industry? And this is what we tried to do, and how we could say we expanded the Active House radar. So with on the planet side, we are using those 3 indicators. So biodiversity loss, CO2 emissions, and then keeping energy, because we know it's still an important measure for buildings, also to get a building permit. And then the indicators for people that are also the same that Benita already mentioned, present in Active House. And we know these are confirmed by science, and no need to challenge those, are really the ones connected to the human senses. So taking care of people in buildings. And we put them together in a model that we call People and Planet model, which is following the same structure of the Active House radar, just changing the sort of planet part. And it looks very, very similar. And it also goes with a scoring system from score 1 to 4, where 1 is the best. So we're using the same approach. And for the people part, we are scoring in the same way as Active House system is scoring. So we're actually making an Active House radar before to get all the results. And then for the planet part, we are following climate science. And how the result of the building. So the LCA results and the biodiversity loss calculation are actually following the path on staying within 1.5 degrees. And I just plugged 1 second my laptop. Sorry about that. Yes. And for the energy indicator, at the moment, we are actually looking into it on which one is actually the most important energy indicator and how to make sure that is close to the local regulation. How can we make it more fair to the local regulation? And we are looking at the actually at the EPBD and how it's being implemented in the different countries. But while we do all this work, we are actually using the same indicators as the active house radar, just making an average of the three indicators for energy. So we hope for better development of that soon. Yes, but I will go through the CO2 emissions and biodiversity indicator because those are the two new, so bringing something new to the radar. And for CO2 emissions, I think everybody knows now the life cycle assessment, so I don't need to explain that. But that is calculating kilos of CO2 equivalent per square meter per year. So we get this number and then we look at it in the reduction path for the global emissions. And then for the biodiversity loss, actually the biodiversity loss is following the same life cycle steps. But what we look at is the offsite, because we know that 95% of the biodiversity loss of a building occurs offsite, and especially in the production, so extraction, production, and transportation of materials. While the on-site can actually support biodiversity, so there are methodologies to actually calculate the net gain of biodiversity. And then for the end of life is also an offsite impact, but we don't have enough data at the moment. It is though estimated to be only 1%, 1 to 2% of the total impact. And at the moment, we have this methodology that has been developed in Denmark, as I mentioned, which is following the life cycle assessment. So taking the life cycle inventory, so all the materials, all the information that we have in the life cycle assessment, that is connected to a biodiversity impact data set. And through that, we calculate an impact score, which is calculated in this weird unit measure called PDF per year, per square meter per year. So it's in a similar way as the CO2, and PDF stands for potentially disappeared fraction of species. So it's a number that goes, it's a fraction, so it goes from 0 to 1, and with 0, there is no impact, and with 1, there is actually species disappearing. So it is, it's giving this information on how big is the impact. And then in Denmark, it has been converted into an easier number to explain, which is the area that needs to be recovered to make up for that impact of biodiversity loss. So instead of communicating this PDF number, then we would talk about hectares of land or square meter that needs to be recovered to make up for that impact. But then how do we score the two core system boundaries indicator? And to explain the scoring system, I will go through this graph that looks complicated, but it is not. I will go through each part of it, and we call it the butterfly model. And it has been developed by a coalition of companies in Denmark in a project that was called Reduction Roadmap. And in this graph, basically, we look at the status of the CO2 emissions and how much we need to decrease and how fast to be within 1.5 degrees of the Paris Agreement. And then at the same time, it looks at the biodiversity recovery that we need to do to help actually restore the ecosystem. So if we start from the first, you see we have a status of the CO2 emissions, and here we have the emission for the building sector in Europe. These are the data that we are using. And 2040 is the target to be within the Paris Agreement, and we know we need to reduce by 96% by 2040. And this reduction can be done in different paths, of course, based on how fast we do it. And of course, it has a probability of happening, and we know that there's different probabilities. So here you can see there are actually 3 lines. So there is 50% probability that we make it, 33% and 17%. And of course, the slowest path is the one that is more likely to happen, and gives us more time actually to do it. But yeah, we should also look at the probability or the scenarios of making it faster. And yeah, and the recovery of biodiversity is actually a mirrored graph that shows that we can recover biodiversity in the same way with 3 different speed. And the recovery means this sort of hectares that I was talking about before. So recovering actually some areas, restoring some areas of land and help biodiversity thrive. And then we have an impact part in this graph that is just showing the impact. We don't use it for anything in the calculation, but it's just showing that if we recover 100% of the biodiversity through the value chain, then we are actually creating an impact also on the CO2, because there will be a CO2 sequestration happening in that area of nature that is actually restored. So this is just to show the double impact, that if we focus on recovering biodiversity, we are actually also improving the CO2. And that's why it's a butterfly graph, because it's a mirrored graph. And how do we score then the 2 indicators, the CO2 emissions and the biodiversity? So if we look at the CO2 emissions first, we have the score 4, 3, and 2, which are based on the probability scenarios to make it by 2040, 2034, or 2031. So depending on the CO2 calculation that you got from the LCA of the building, then you place it on the graph, and you see in which reduction path you actually are. And then the score 1 is only for projects that are not increasing the pressure on the planet. So it's projects that are able to reduce emission. So it means that it's a renovation project, that the CO2 payback time of this renovation is actually lower than the lifetime of the building. So it means, for example, a project where we have done some renovation on the energy performance, using, of course, some materials, but all those materials that have been used have a CO2 payback time that is lower than 50 years. And this is actually possible. We have seen it with some studies that we're doing internally in VELUX, that if you just renovate a house from the 70s and you make it more energy efficient, that is actually a score 1, because you have a payback time, a CO2 payback time that can be around 10 years, 10, 15 years. So that's extremely good, and it's really pushing for more renovation. And yes, and the biodiversity loss works in the same way. So we look at the score 4, 3, and 2 for the different reduction or recovery path, so how fast we do it. And then the score 1 is the one very difficult to achieve, because it would be recovering more than the 100% of biodiversity right away. But yeah, of course, that is for pushing more the industry in actually acting. And here I have an example, which is the new VELUX LKR Innovation House. It's a new office that we have in Denmark. It's a transformation project. And we use this model to show the performance of the building. And in this case, we have the CO2 emissions that is a score 2 because it used to be a warehouse. So it was not heated building. So now it's actually using energy. So it cannot be score 1 because the CO2 payback time is a bit longer, of course. And then the biodiversity loss is a score 2 because we have done the calculation. We know how much is the impact. We found out that we need to recover or restore 11 hectares of land to make up for the impact of this building on biodiversity loss. And we're still in the score 2. It shows that you're still on time to do it by 2030. So we are looking into how to do this kind of recovery project because it's not really straightforward for a player like us in the industry to start a project like this. And just to conclude, I want to mention that this work was done by VELUX, but in coalition with other partners as part of a bigger framework that we're working on how to look at buildings, and especially how to focus on renovation. And our partners are Artelia, BPIE, Building Performance Institute Europe, and No Objectives.